All right, today's lesson is on using the substitution method for definite integrals. The key here is we have a definite integral, so we are evaluating it at a specific points. So we don't have to substitute back in. What we're going to be doing is changing the bounds of integration. So anytime you kind of have an inside function and an outside function, the inside is really what we want to be u in most cases. So here I'm going to let u equal 4x minus 2, which means du is equal to 4 dx. So before I do my substitution, I'm going to rewrite this as the integral from 1 to 2. I want a 4 dx. I'm going to put a 4 here, but I need to undo that, so I'm not actually changing what the problem is. 4x minus 2 cubed dx. So we are going to change the limits, and we're going to do that by plugging them into this here. So we're going to plug 2 in, so 4 times 2 minus 2, so that would be 8 minus 2 is 6. And then we're going to have 4 times 1 minus 2, which is going to be 2. So my new problem, we're going to have 1/4 times the integral. My bounds are now going to be 2 and 6. My u is 4x minus 2, so we're going to have u cubed. And then the 4 dx is going to be my du. And then we just integrate like normal. So we're going to have 1/4 u cubed integral is 1/4 u to the 4. And we're evaluating this from 2 to 6. So this is now going to be 1/16 times 6 to the 4 minus 2 to the 4. And if you know what 6 to the 4th is good for you, but you can go ahead and type this into your calculator and get 80. Now the nice thing here is, since these are definite integrals, you can check your work using the calculator. So once you do this, you want to be able to do this without a calculator, but you can check your work by just typing that in the calculator and see if it matches. Okay, so my next one here is the integral from 1 to negative pi to 1 plus pi of secant squared 1/4 x minus 1/4. So I'm going to let u equal 1/4 x minus 1/4. So my new limits of integration are going to be 1/4 1 plus pi minus 1/4. Well, we're going to have a 1/4 minus 1/4, so this is just going to be pi over 4, because we're going to distribute. And then my lower bound is going to be 1/4 1 minus pi minus 1/4. So we're going to have 1/4 minus pi over 4 minus pi over 4. So this will be negative pi over 4. du is going to be 1/4 dx. So again, I'm going to rewrite this before I do the simplification. So on the inside, I need a 1/4 dx, so I need to put a 4 on the outside. And then 1 plus pi, 1 minus pi. dx. Now we're going to do all of our substitutions. The 4 is just going to go along for the ride. My new limits of integration are negative pi over 4 to pi over 4 of secant squared u du. Then we integrate. So the integral of secant squared is tangent so our integral is going to be 4 tangent of pi over 4 minus tangent of negative pi over 4. Well, this is going to be 4 times tangent of pi over 4 is 1, tangent of negative pi over 4 is negative 1. So this is going to be 4 times 2, which is 8. Our next one here, my inside function is going to be x squared, so I'm going to let u equal x squared, which means my new bounds are going to be pi and 0. du is going to be 2x dx. So in the problem I have a 6x, so I'm just going to break that down, and this is going to be the same as 3 times 2x. So the 3 is going to stay, and then the 2x is going to get replaced. So my new integral is going to be from 0 to pi of 3 sine of u du. So the x squared gets replaced with the u, the 2x gets replaced with du, and then the 3's there. This integral is going to be negative 3 cosine of u, evaluated from pi to 0. So negative 3 cosine of pi minus a negative, so plus 3 cosine of 0. So this is going to be negative 3 times negative 1 plus 3 times 1. So we'll have 3 plus 3, which gives us 6. Right, our next one, I'm going to let u equal this whole thing under the radical. So u is going to equal x squared plus 6x minus 1. u is going to be 2x plus 6. My new limits, if I plug 1 in here, we're going to have 1 plus 6 minus 1. So that's going to be, that's a plus 1. 1 plus 6 plus 1 is 8. If I plug in 0, we get 1. And it should be dx. So I sort of have this. So what I'm going to do, and this is going to be a little bit interesting. So I'm going to multiply that by 2 so that I get 2x plus 6 on the top, and I'm actually going to put a 2 on the bottom as well so that it cancels it out, and I'm actually going to leave it on the inside this time because of the square root, and you'll see where this is headed. So this is going to be the integral. My new bounds are 1 to 8. The 2x plus 6 dx is now du. The 2 is still there, root u. So the reason I left the 2 on the inside rather than the outside is the integral of 1 over 2 root u is just root u. So this is going to be the square root of u, evaluated from 8 to 1. So this will be the square root of 8 minus the square root of 1. And if you wanted to simplify it further, you could make it 2 root 2 minus 1. This next one, you could choose either of the functions to be your u. It'll just change a negative, but it'll end up being the same answer. So I'm just going to let u equal sine of theta. So my new bounds, sine of pi is 0. Sine of negative pi over 4 is going to be a negative root 2 over 2. du will be cosine theta. So we'll rewrite our problem. This is going to be the integral from negative root 2 over 2 to 0. Sine gets replaced with u, cosine d theta, keep reading that part, is going to get replaced with du. Now we'll do the integral. So this is going to be 1/2 u squared so we're going to have 1/2 of 0 squared minus negative root 2 over 2 squared is going to be a positive 2 over 4, which is really 1/2. So we're going to have 1/2 times negative 1/2 will give me a negative 1/4. Okay, for this one it says find the integral from 2 to 4 of f of 1/2 x if the integral from 1 to 2 of f of x dx equals 4. So this is the one we're trying to find. So I'm going to let u equal 1/2 x, which means my new bounds would be 2 and 1, which is good news since that's what those ones are. Du is going to equal 1/2 dx. So I don't have a 1/2 here, so I'm going to go ahead and rewrite this over here. So I'm going to introduce a 1/2 into the problem, which means I also need to undo that by multiplying by 2. Okay, so this is now going to be 2 times the integral. My new bounds are 1 and 2, and then we have f of u du. So this integral is 2 times this, and if this is 4, then what I'm looking for is 2 times 4, which is 8. All right, this next one, we're going to do some fancy work here. We're going to evaluate this integral, and we're going to let u equal x plus 2 after completing the square, just when you thought that would go away. All right, so we're going to do some algebra first. So it's going to be the integral from -2 to 1. First thing I'm going to do is rewrite this as 5 minus, and then in parentheses 4x plus x squared. And then we are going to complete the square. So we're going to have -2 to 1. We're going to have the square root of 5 plus, and I'm going to put a little square just to make your Algebra 2 teachers happy, minus, and then I'm going to rearrange these so it's x squared plus 4x plus square. Now this is going to be a plus. I want you to see algebraically we're subtracting all of this, so this would be negative, which is, so whatever we put there, this will be the positive counterpart. So again, we're not changing anything, we're just changing what it looks like. So the value that's going to go here that would make this a perfect square factor is 4. If you don't remember how to do that, you take 4, divide it by 2, which is 2, and square it, or just think about it logically in your head. Whatever we do here is here. So this is now the integral from -2 to 1 of the square root of 9 minus this perfect square is x plus 2, which makes sense since they said u needs to be x plus 1, or x plus 2. So u is x plus 2, so my new limits of integration are going to be 3 and 0. Du is dx. So this will be the integral from 0 to 3, the square root of 9 minus u squared, du. Okay. This one we're going to do geometrically. Okay, the square root of 9 minus u squared is a semicircle. So it is this. We're interested in the integral from 0 to 3 So I'm not going to do any calculus, we're going to do some geometry. So this is going to be 1/4 of a circle. Pi, my radius is 3. So my answer is going to be 9/4 pi. So in this problem, we did algebra 2, we did geometry, and a little bit of calculus. All right, here we're going to let u equal 4 minus x. So my new limits, 4 minus 0 is 0, and 4 minus a negative 5 would be 9. Du is going to be negative dx. Okay, so we're going to have the negative, I'm going to pull out, so we'd make it a negative and a negative. My new limits are going to be 9 to 0. This x we haven't gotten rid of yet. We will, but not just yet. Times the square root of u du. Okay, so I'm going to do a couple of things here. First thing I'm going to do is I'm going to rearrange this. If this is the integral, we're used to seeing the bigger number on top and the smaller number on bottom. And if they're switched, it's opposite. So I can combine this being negative and these being backwards and just rewrite this as a positive 0 to 9, which makes our linear brains happy. Now we have to deal with this x. We're going to use this statement. We're saying u equals 4 minus x. So that means x is going to equal 4 minus u. I can add x over and subtract u. So then I can replace this x with 4 minus u. So we can do multiple substitutions as long as everything stays true to this original thing. All right, so have we made our lives any easier? We still have some weirdness, but we actually have. So we're going to rewrite this as 0 to 9 of 4 minus u. I'll rewrite this as u to the 1/2. Here, we can't multiply the x in, but here we can just distribute and just make a polynomial out of this. So this is going to be 4u to the 1/2 minus u to the 1 times u to the 1/2 is going to be u to the 3/2. And then we will integrate. So we're going to add 1 to the power. I'm going to leave a space here. So add 1 to this is 3/2. So to undo that, I'm going to have 2/3. Minus, leave a space again, u, I'm going to add 1, so 5/2. So we're going to multiply by 2/5. And this is going to be evaluated from 0 to 9. So we're going to have 8/3 times 9 to the 3/2 minus 2/5, 9 to the 5/2 minus, this would be 0 and this is 0. So we just have this, and you can plug this in and get some simplified, but it gets kind of ugly. So if it was a problem, you'd either leave it like this or they'd be nicer numbers. But this ends up being negative 506 over 15. So this one, we're going to let u equal 9 plus x squared. So we're going to have 9 plus 16 is 25, and 9 plus 0 is 9. So I'm going to rewrite this. Well, du is going to be 2x dx. So we have an x cubed here that we can work with. So if I wanted to, I need a 1/2 on the outside. I'm not going to do the substitution yet. I'm going to rewrite this as 2x times x squared, square root of 9 minus x squared. Okay, so let's look at what we have. 2x taken care of. This will get replaced with our u. We still have this x squared, though, that needs to be dealt with. So again, we're going to rearrange this and make a substitution in terms of u. So we need x squared alone. So x squared is going to equal u minus 9. And that's what we'll replace here. So my new integral is going to be 1/2. My new limits are 9 and 25. The 2x dx gets replaced with du. X squared gets replaced with u minus 9 times the square root of u, which I'm going to write as u to the 1/2. Because again, we're going to distribute that through now. So u times u to the 1/2 is u to the 3/2 minus 9u to the 1/2. And then we'll integrate. So we're going to have 1/2 times, this is going to be u to the 5/2, so I'm going to multiply by a 2/5, minus 9, leave a space, u to the 3/2, so we'll need to multiply by 2/3, evaluated from 25 to 9. So we're going to have 1/2, and you can simplify whatever. So 2/5 times 25 to the 5/2 minus, this would end up being 6, so 6, 25 to the 3/2 minus 1/2, 2/5 times 9 to the 5/2 minus 6 times 9 to the 3/2, which again is big and ugly, and you can power through or just type it in your calculator, and that's what you end up getting there. All right, this one we are told what the substitution is, and we're just going to find the equivalent from our multiple choice options. So let's just start with u equals the square root of x minus 1. So my new bounds, we're going to have the square root of 5 minus 1, which would be 4. Square root of 4 is 2. And then if we plug in a 2, 2 minus 1 is 1. Square root of 1 is 1. So right away, I can eliminate those two options because they don't have the right limits. Du is going to equal 1 over 2 root x minus 1 dx. Okay, well, that's not super helpful because here I've got u, right, x minus 1, but I don't have another x minus 1. But we're going to be clever, and if u is the square root of x minus 1, then this is equal to 1 over 2 u, dx. So that we're going to introduce into the problem, which is fine because it's in terms of u. So dx, I'm going to multiply this over. 2u du equals dx. So we're going to replace the dx with something entirely in terms of du, which is 2u du. So let's see where we're at. Our new limits are 1 to 2. This square root of x minus 1 is going to become u. The dx is going to become 2u du, but I still have this x to deal with. Okay, so let's go back to our original here. So u squared is going to equal x minus 1. So x is going to be u squared plus 1. So this will be the integral from 1 to 2. I'll go ahead and multiply this 2u and the u. So that gives me 2u squared over u squared plus 1 du. And then we match. So our answer is going to be E, 2u squared over u squared plus 1. And that's how we do definite integrals using the substitution method.